we are going to discuss single linked list. Single linked list. So in this, there are various operations. First one is creation. Second one is traversing. Generally, we will use display the nodes, adding the nodes. Third one, delete the nodes. Delete the node. So coming to the first one, so node, I already told you, this one is data, this one refers to next. Okay. So for example, data is say 10. Next is refers to the address of the next node. But here this is a single node, means the next have no address. So whenever there is no address means we will represent it by using the none. So these are the basic two important fields required to define a node. So to create a node in Python by using the class, I hope you all have some basic knowledge of Python, because that will help you understand the implementation more easily. So now I am going to create a class. What is the name of that class is node. In this node, two fields are there. One is self dot data is equal to data. Self dot next is equal to none. So just these two fields are represented here. So whenever we are going to create a node, these two fields are initiated. So for that, I am going to use to construct a initiator mechanism. Here this is ini initiator mechanism. Constructor initiating, parameterized constructor, this one here, self comma data. As I told you, you are already aware of the Python, then only you will able to understand easily. Okay. So these are the basic fundamental steps to create a node. Okay. Create a node. So I will implement in Python one by one also immediately. Go to the Python implementation, new file. Here first class node. Okay. Constructor initiation, define underscore underscore init underscore underscore self comma data. Okay. Self dot data is equal to data, self dot next is equal to none. Okay. With this completion of the creation of the node, coming to create a another class for the single linked list. Another class for the single linked list. So next class single linked list, single linked list. If there is no node in this list, what happened? I already told you, always the first node is referred to head. Always the first node is referred to head. That is, it is very very important. We always traverse the nodes starting from the head. So always the first node is head. That is the fundamental rule in creation of the linked list. So for that, this is a here the only one node, that is my head, that is self dot head. If it is one node, if it is no node, what happened? If it is no node, what happened? Simply self dot head. There is no node, so that it is none. Even though to initiate the single linked list, we are going to use again constructor underscore underscore init underscore underscore self. Okay, this is the creation of the linked list. Second part, this is a creation of the linked list. Second part. Now I am going to implement in the Python also as well as. Now enter back button, create class single linked list, single linked list, define underscore underscore init underscore underscore self. Self dot head is equal to none. Self dot head is equal to none initially. Okay, for the understanding purpose I will give some gap. This is two blocks. Okay, now we are going to display the nodes or traversing the nodes. For that I am going to use one more function, that is to define a function name, it is display. Okay, it is used to display the linked list. This is used to display the linked list. Display the linked list. Okay, so for that, the what is the fundamental step is, if there is no node in the list, suppose there is no node created by the user, so then we will go for condition statement. If self dot head, if self dot head is none, if self dot head is none, immediately what you will display, print linked list is empty, linked list is empty. Again, now go to the Python implementation here. Yeah, define display self if self dot head is none. If self dot head is none, print linked list is empty. So what we will do is, next we will create an object for the execution of the single linked list. For that I am going to use the SLL is my object. SLL, single linked list. You will just copy this one to create the object. Control C, Control V. Yeah. So now create the object is created. Now you will call SLL dot display. Simple. There is no parameter passing to the display. Just you will non-parameter is it function, that is display. So you no need to pass any parameters here in the display. Now run, create SLL one single linked list one. See, observe, linked list is empty because we have not created so far any nodes in this. So that means simply it will print the linked list is empty. Okay. So now we will create the nodes. How to create the nodes? We will create the nodes. So first node. So this one is n1. So to create n1, n1 is equal to node of 10. What happened? Immediately n1 is created and data is 10. And if it is a first node, so in this next it is none. It is none if it is first node. Next, always if it is a single node, the first node is refers to head. That is very very important. So that SLL, we have already created a single linked list object. So for that SLL dot head is equal to first node. So that is n1, because here the only one node is there, n1. I am not creating any other nodes till now. So that first node is n1, first node is head. Okay. Now I am going to create second node, that is n2 is equal to node of 20. So now created node 20. Here we will store the address of this node in this field, next field n1. So how to represent this one? This one is n1 dot next, this one is n1 dot data. So for that n1 dot next are automatically, if you created the already the first node is n1 and first node is head, so that you will give SLL dot head dot next is equal to this one n2, that is n2. So that means, for example, this address is 111100, this address is 1200, this address is 1300, this address is 1400, for example. So that here what happened, this none is removed. Now you will write this address, n2 node address is 1200, that is right here 1200. Okay. Now coming to This one is n3. Now in n2 dot next is what it is? It is simply none. Okay. Now coming to this one, create n3. N3 is equal to node of 30. So now n3 is created, 30, here it is none. Now what we will do is, this is n2, n2 dot, what is this field is next. So n2 dot next, n2 dot next is equal to, what is this one? Address of the next node. What is the address? 1300. So you will remove this one, you can place 1300 here. So 1300 is nothing but n3. So that is n3. Here you will write n2 dot next is equal to n3. Okay. Next one, n4 is equal to node of 40. Now it is created 40 and none. This one is n4. Now tell me what? This one is n3. This one is n3. So n3 dot, this field is data. This field is next. So n3 dot, we have used next is small lowercase. So n3 dot next is nothing but address of the next node. Next node name is n4. So here what happened? Whenever you will write the statement, the address of the next node n4 is shifted to here, that is 1400. This one is shifted to here 1400. Now link has been formed. So this is link, this is the link, this is the link. Only single linked list. So last one is also none. Okay. So if you store the address of this first node in this, it will create a circular linked list. We will discuss in the next sessions. So these steps are used to create the nodes. But how to display the nodes? How to display the nodes? Already we have written some code here. If this statement is not true, go to the else part. What happened in the else part? We will traverse the each node and verify the, if there is a node, in that node what data is present. So for that I am going to use one variable that is temporary. So that is temp, that is temp. So for that here I am going to write temp is equal to, temp is equal to self dot, self dot head. Temp is equal to self dot head. This one is head, this one is first node is self dot head. So now I am pointing this temp starting from the head. Okay, now verify, now verify temp dot data is 10. So that is printed. So here you will write one print statement, that is print temp dot data, print temp dot data. Now, after printing that, after printing the temp dot data, then what we will do is this temp is moved from this node to this node. So how to move this node? By writing one statement, temp is equal to temp dot next. Temp is equal to temp dot next. Understand what is temp dot next? Temp dot next is 1200. Now it is temp. Now temp is equal to 1200 means here where is 1200? This is 1200. Now temp moves from this place to this place. Temp. Again print the data. So here you will write one more sentence, that is temp is equal to temp dot next. So again now this statement is printed. So now 1200 change it to 1300. Now temp move from this place to this place. Again temp dot data as printed. Now again move to temp is equal to temp dot next. Now temp dot next is 1400. So remove, this is 1400. So temp move from this place to this place. Okay. But if you observe what happened, whenever temp reaches to the last node, here you simply, if it is any node is presented, then the data has been then the data will be printed. Otherwise you will write one more statement, that is while temp while temp is while temp is not none, while temp is not none. So whenever there is no data, whenever the temp is none, then automatically it is exit from the loop. Sometimes you will write simply while temp, you will not write this one. For example, here you will write like this, while temp. That means if it is true, then only it will execute the remaining steps, otherwise it will come out from the loop. So now we will go for the implementation part. Here what happened here, else, coming to this one, temp is equal to self dot head, while temp while temp is not none, while temp is not none, print temp dot data. For my convenience I will use this symbol and so this and operator. Okay. By using this symbol we will print the on a horizontal way, 10, 20, 30, 40, like that. Okay. So next temp is equal to temp dot next. So now here we will create nodes. What is that node? N1 is equal to node of 10. So SLL dot head is equal to N1. N1 N2 is equal to node of 20. Write N1 S SLL dot head dot next is equal to N2. Now create N3 is equal to node of 30. Okay, node of 30. Now n2 dot next is equal to n3. Now n4 is equal to node of 40. Here n3 dot next is equal to n4. That's it. Now run, execute it. Invalid syntax here. Yeah, just put in inverted commas. Execute this. See, in this way. So this is your code. Okay, this is your code. I am removing these gaps. If anyone take the print screen, okay, or reduce the size. Okay, your output. This is the output. So with this, I will stop this session. In the next session, how to add the node to the linked list. Okay, thank you.